The question that I have is, how do we determine OCR from a lab test? OCR here refers to over-consolidation ratio. So there are some interesting experimentally observed facts, right? So now the question is, can I use some of these facts to establish the pre-consolidation pressure of a field soil sample? To answer this question, let us consider the following first. Supposing, say, about 10 million years ago, on this particular site there was soil slurry. And this slurry, over the years, due to its own weight, became densified. In other words, it became consolidated and became a normally consolidated soil. Now let's consider a point 10 meters below in this normally consolidated soil. Supposing, say, the buoyant density of the soil is 10 kilonewton per meter cubed, and therefore the effective vertical stress at that point would be 10 times 10, which is 100 kilopascal. If I were to plot the variation of E versus sigma V, it would have followed this path, the virgin compression curve, up to this point where the pressure is 100 kilopascal. Say down the road, about 5 million years ago, this top 5 meters of soil got eroded away. What does it mean to point A? Well, it got unloaded. This much of soil has been removed, right? So that's like unloading. Assuming that the density remains the same, the effective vertical stress now is 50 kilopascal. So the vertical stress decreased from 100 kilopascal to 50 kilopascal. Without knowing anything about this history, say a few days ago, we went to the site, drilled a borehole over here, took a sample from point A, brought it to the laboratory, and did a consolidation test. When we take the sample out of the ground, we are further unloading it. We are decreasing the vertical stress all the way to 0 here, right? So in the laboratory, starting from a 0 vertical stress, we're going to gradually increase the vertical stress step by step. What kind of E versus sigma V relationship are we going to get, do you think? Well, this is what's going to happen. It's going to go back along this curve, and then as soon as it reaches this point right there, it's going to follow this virgin compression curve. So there is going to be a break, and that break tells you the value of the pre-consolidation pressure. And in knowing the history in this particular case, we know the break is supposed to take place around 100 kilopascal. In other words, the experimental curve is going to reveal the pre-consolidation pressure to us. But of course, there's a little bit of difficulty here. Recall what I said, the swelling curve and the reloading curve do not exactly coincide with each other. So when it goes back, it doesn't really abruptly change into the virgin compression curve. So there is a smooth transition, and we need a special procedure to establish the pre-consolidation pressure, right? There are a couple of methods of doing that. One of the methods was developed by Casagrande. Say the curve from A to C looks like this. So there's a gradual change over here. Well, this is what you do. First, you identify the point where the curvature is minimum. Let's say this is point A, right? Then you draw a horizontal line at point A. You also draw a tangent at point A, okay? And then usually you will find a straight line part over here. You extend that straight line part, all right? And then this middle line is the bisector. So wherever this bisector intersects this extension of the straight line part, okay, you mark that point, and that point corresponds to the pre-consolidation pressure. I know my picture is somewhat convoluted, so I would refer you to the book, which has a slightly more clear picture. So we have this empirical method of finding the pre-consolidation pressure. So once we find the pre-consolidation pressure, we can come back and now define the over-consolidation ratio. So in our example here, the pre-consolidation pressure is 100 kilopascal, but the actual vertical pressure currently existing in the field is only 50 kilopascal, and therefore the OCR is 100 divided by 50, which is equal to 2. I have written that over here. Well, sometimes I'm using the total vertical stress, sometimes I'm using the effective vertical stress, and I'm pretty sure I have confused you thoroughly. Well, let's sort this out. Remember I talked about the process of consolidation, right? What does it exactly mean? We haven't really talked about that yet. Once we do, these things will become clear. On second thought, well, this video is getting a little too long, so I'm going to explain this in the next video, okay?